Okay, this lesson, we're going to get started by looking at some transformations of functions. And so we'll just do a couple of examples here. We're going to start by looking at shift transformations. So that's when there's a little bit of addition or subtraction that's kind of put into the function. So if you look at the four examples of what I'm going to graph here, we have an absolute value function on x. And then you can see various additions and subtractions either taking place inside the absolute value function or outside of the absolute value function. And so we'll just have a look at what that's actually going to do to this picture and make a conclusion from there that we can generalize to other functions. So y equals absolute value of x. What I'm going to do is just start filling in some tables of values here. Xy, xy, xy. And yeah, so I always like my tables of values to center around 0. And so I'll do 0, 1, 2, 3, -1, -2, -3. And then I'll just do that for the rest of them as well. Okay, so looking at the initial function, the absolute value of x, so if you remember basically what that function does is it just turns negatives into positives. One way of looking at it, it's the distance of your number to 0. So -1 is 1 to the left of 0, so its absolute value is actually going to be +1. 0 is a distance of 0 from itself. 1, 2, 3 are just themselves because they're positive. The easiest way to do these calculations is just ignore the negative, basically. So we're going to get that collection of points. So that's going to actually give us points, right? So for example, that -2 and 2 is actually x is -2 and y is 2. So we can find that at -2 and 2. And then similarly, we'll have, let's see, make it go right to that point, -3 and 3. Draw these. Yeah, that's right. -1 and 1, 0, 0, 1, 1, 2, 2, and 3, 3. And so if you haven't seen an absolute value function before, it's basically just a line that sort of bounces back at the origin. So I'm just fixing that -3 and 3 dot there. So it's a line that sort of bounces back up at the origin because the behavior changes when we get into the negatives. And so we get this sort of V-shaped curve. And it'll look like this. And it should just sort of go like that V, basically forever in both directions. And so what we're going to do is now look at the remaining functions here and just sort of see how it moves the graph around. So what I'll get here for absolute value of x plus 4. So for the first one, that's 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. 3 plus 4 is 7. Now on the left side, I'm going to be a little bit careful here because it's not going to be, I have to be careful when I take that absolute value. So it's actually going to be 1 plus 4. Right? Because I'll take the absolute value of -1 first and then add 4. This one will be 2 plus 4. And then the other one's going to actually be +3 plus 4. So I just wrote a little bit of rough work in there. And if I actually calculate those now, I end up with 7, 6, 5. And so what you can see there is basically it's all the values of what we had there on the left because it's that same absolute value, and then you just add 4 to whatever we had on the left. And so graphically, that's a 4 that's going to get added to our y values. And so I can see here I've got 0 and 4, and then 1 and 5, and -1 and 5. And it looks like I need a little bit more height to my graph. And yeah, so then I've got 2 and 6, 3 and 7, negative 2 and 6, negative 3 and 7. And what we can see, it's that same V shape, so it's the same picture really. And it's going to go upwards, same thing. And yeah, it's the exact same picture. So if we look at what the effect of that +4 has done, you look at that 0, 0, it's actually bumped up to 0, 4. Everything has gone up by 4. So that's essentially what that effect is going to do for us. All right, so we're going to have a look at the next one now. Again, I'll do a little bit of rough work before actually doing the calculations. And so the first one, let's say I plug in this -3. I actually now I'm going to do that -2 before the absolute value because it's inside the bracket with it. So what I'll have for this is actually -3 minus 2 is -5. And then I'll do the absolute value. I'll do the absolute value of -4. The absolute value of -3. 0 minus 2 is -2. And 1 will be the absolute value of -1, the absolute value of 0, and the absolute value of 1. And so now if I do those calculations, the absolute value of -5 is 5. 4, 3, 2, 1, 0, and 1. And so what we can see here is that sort of reverting behavior is going to happen somewhere else. So let's plot my points. I have -3 and 5, -2 and 4, -1 and 3, 0 and 2, 1 and 1, 2 and 0, and then actually 1 and 3 here. And so the shape right now isn't quite looking the same, but that's because that key point, that vertex, is actually moved over a little bit. And so hopefully you'll believe me, if we plug in 4, we'll get 4 and 2, right? That point would go right there. 5 minus 3 is 3, so we'd have 5 and 3, and it would keep going in that direction. And so what we are seeing is, again, basically the same shape, that V, except it's actually moved to the right by 2. And that might come at least a little bit as a surprise, because it's a -2 inside of that bracket. And what that -2 is doing is actually shifting it in the positive direction right by 2. Now, the reason for that is because the sort of key behavior, that behavior change, that vertex point of this V-shaped curve, is when we plug 0 into the absolute value, right? That's right when we get the 0 here, or the 0 here, when we plug those in, that's where we get that change in the line. That's where it bounces up, and it's because the absolute value switches from positives to negatives. It sort of changes the definition of the function. So in this equation over here, when we have that x minus 2 inside the bracket, what's actually happening here is that we have to find the x that makes that inside equal to 0. So what we're essentially doing is solving this equation, x minus 2 equals 0. And to solve that equation, we have to add 2 to both sides. So 0 plus 2 is 2. That's why it's going to kind of be opposites to things that happen inside the function. All right, and so for the last one, I'm not going to do the rough work. I'll just do the calculations here. Hopefully you believe me. If I do 0, I'll get 1 minus 3 is -2. If I plug in 1, I get 2 minus 3 is -1. If I plug in 2, I get 3 minus 3 is 0. And 3, I get 4 minus 3 is 1. If I plug in -1, I'll get 0. Minus 3 is -3. And then be careful on the other ones. If I plug in -2, I am going to get -2 plus 1 is -1. The absolute value is +1. So 1 minus 3 is -2. And then again, -3 plus 1 is -2. It's going to flip to +2. And then -3 is -1. So I'm going to plot these points, -3 and -1, -2 and -2, -1 and -3, and then 0, -2. So we can see there's that bounce there. 1 and -1, 2 and 0, and 3 and 1. Yeah, so if we put this together, again, hopefully you can see that V shape occurring. And hopefully you'll believe me in what's happening here. So let's say I highlight this -3. So what that did was it pushed your vertex down by 3. And in fact, all the other points, not just that vertex, everything dragged along with it. And then that +1, you can see it actually moved everything to the left by 1. And so just a conclusion for what we've got here, and then we'll do one more example. So if we have y equals f of, and so make sure I use the right letters here, x minus h plus k. So what we've got here, that minus h is occurring inside of the function. So it's like the -2 in C or the +1 in D that occurred inside the absolute value. Or that plus k is occurring outside the function, like the +4 or the -3. Then what we're going to get is the graph will be shifted. And so what we'll have there is it'll be shifted to the right by h, and then up by k. So essentially it's saying that h affects the horizontal. It's going to move it left to right. So I'm going to put in a bracket there. It'll be left if h is negative. And similarly, when we say up by k, for example, in the D example, it actually will go down if k is negative. Oh, there's a symbol there and it's making it hard for me to draw. There we go. Sorry, that's a little slanty. Otherwise, I press a button. Yeah, so essentially anything that, if that h is occurring on the inside, then it's strictly going to affect the horizontal of your graph. And if we have that k on the outside, it's going to affect the vertical of that graph. All right, so I'm going to write down another example, and maybe I can make it at least a little bit application-y. All right, so just kind of move your conclusion up at the top from what we found using those absolute value graphs, and I came up with at least somewhat of a maybe contrived application of how we could use these transformations. So what we're going to talk about is a revenue versus quantity function. And so we've got Pete, the table maker. So he makes and sells tables for profit. His monthly revenue, so it's in thousands of dollars, just so it makes a little bit of sense, versus quantity sold is graphed below in blue in the first graph. And so we're going to look at what happens in these different scenarios that might affect his revenue versus quantity. So in the first one, he's going to be given a monthly grant of $2,000 to make these tables, maybe like a small business grant. In part B, he's actually going to just donate the first table to charity. So that's obviously going to affect his quantity. And in C, it's going to be a little bit of a mix. So he's going to get a monthly grant of $3,000, and he's going to donate his first 2 tables to charity. And so that's going to affect everything really there. So first of all, what I'm going to do is translate these to that function notation. And then what we'll do is look at what that's going to do for the graph. So if he's getting a monthly grant of $2,000, that's straight to revenue, right? So what that basically means is that revenue goes up by $2,000. So in our function, what we'll actually have is y is r of x. And so we're just going to add to that r of x. Now, what I'm going to do is just actually add 2. And the reason for that is because it's measured in thousands of dollars, so 2 actually represents $2,000. That's why. So it's not plus 2,000. 2 represents 2,000. So that's going to be r of x plus 2. And so what that tells us is that our graph goes up by 2. And that should make sense in the context of what this question's asking. So y is going to go up by 2. So in my graph. So what I'm going to do is go over here and get this started. I'm going to label these kind of key points that I've put here. So we've obviously got 0 and 0. And this one looks to be at 3 and 3. And this one here, that's the big one there is my 5. So it's 2 over, and it looks to be about 7 and 5. And so what I'm going to do is take all of those points and move them. Well, I'll draw these key points. That would be 3 and 3, and then 7 and 5 is about here. So that sort of dotted blue line that I'm drawing is the initial graph. And so what I'm going to do is just move all those key points up by 2. You can do that either by visually just counting up 2 ticks for each of them, or you can take the coordinates on the left and say the y value is at 0, so the new y value is at 2. The y value is at 3. X doesn't change, but the new y value goes up by 2. And then finally, 7 and 5, x doesn't change, but 5 goes up by 2 to 7. Or we can just visually add 2 to the height, whatever you prefer. And so now I'll connect the dots because in the initial graph, my dots were connected. And it should look something like this. So we could have also actually come up with a pointwise function to describe what r of x is doing initially, and then just applied these things to that pointwise function. But it's a lot of work, and it's actually really tricky dealing with the horizontal stuff in there. So we don't really want to do that. So this is just going to push all our revenues up by 2 on this graph, and the red one should be the new one. Okay, so for B, this one's a little bit more interesting. Here he's going to donate his first table to charity. So I'm going to assume that we're starting from the initial conditions. We're not building off of A. So he's going to donate the first table to charity. So this means that quantity is going to get, the quantity sold specifically is going to go down by 1. So one way of looking at that, that's x is going to become x minus 1. And so my curve, or my function, if I rewrite this, it's going to be y equals, so my x has to now become x minus 1 plus 2. And so what that actually is going to do is shift my graph to the right. Now, this seems a little bit strange, but it's going to make sense when we actually plot this out. So again, I'm going to start with the initial graph of 0, 0, 3, 3, and 7, 5. And Yeah, okay, it's a little bit weird because they're connected lines, which does mean that maybe he's making 1.5 tables, but maybe somebody only wants to buy half a table. Who's to judge? So I'll just draw kind of a dashed line to connect these things. And so, yeah, I'm going to actually move all of these points to the right by 1. So that's what that's going to indicate for us. So that 0 point is actually now going to go to 0, 1. So the x gets moved to the right by 1. 3, 3 is going to become 3, 4. I'm getting those completely backwards. Sorry, that's 4, 3. And that also means that my other point, while I said it out loud, I actually did it backwards. So x is 1 and y is 0. X goes up by 1, y stays the same. And then this point over here, the x is going to go up by 1, so that'll go to 8 and 5. And then again, we're going to connect the dots. And so maybe like intuitively, it might still be a little bit weird that we're pushing this thing to the right because you're thinking right means bigger, right? X is getting bigger. We want X to get smaller. But now if you actually look at the graph, it should actually kind of make a bit of sense. You can see that this new graph is actually underneath the blue graph. It means that his revenues dropped a bit, which should make sense if he's giving up a table every month. And so this basically should be what would happen. You'll notice that we don't have points between 0 and 1 because if he's committed to donating a first table to charity, he can't only make half a table in the month. So this graph, this shift to the right, actually makes a lot of sense. And so finally, the last one, I'll maybe just go through this one a little bit more quickly because we're just sort of putting everything together. So the monthly grant of 3,000, this means R goes up. So R becomes R plus 3. Right, the new revenue is R plus 3, and then donates the first 2 tables. So that's going to mean that X is going to become X minus 2. And so my function is going to be R of X minus 2 plus 3. That's for C. And so what that means is it's going to go right by 2. And up by 3. And so I'm going to shifts, I usually just do them all in one go instead of like 2 separate actions of right then up. And I think I might need one more tick mark there. And yeah, so I'll draw this one in orange. So right by 2, up by 3. Right, so that 0, 0 is going to go to 2 and 3. 3, 3 is going to move right by 2, so 5 and 6. And that last point, 7, 5 should go to 9, which I guess I need to label. And then up by 3 to 8. That's not where I wanted that point, sorry. Got ahead of myself. So over 2, up 3. Yeah, so that should be at 9 and 8. And just connect the dots. I'm going to do this one without the line, so hopefully it goes okay. Nope, didn't work. Straight lines for the win. So yeah, so you can see from this new graph, overall his revenue actually does seem to go up because the graph's higher. He is donating 2 tables, but he's getting more than enough to compensate for that. So that's why his revenue is generally higher. So yeah, the example's a little bit contrived in reality, but it is an example of where you might use these shifts. Realistically, in your future math, you'll almost never see these things again, but it's always a core part of this course. So yeah, so that's the gist of your shifts. They are these additions, subtractions that are occurring in your graph. And the theme is things that happen on the outside, that plus k. It affects the vertical in exactly the way it looks like it should. It moves your vertical up by k. Things that happen on the inside, that minus h actually goes to the right by h. So it's actually sort of the opposite of what it looks like. And that'll be consistent through the other transformation.